Hi everyone. Alright, we are in geometry. We are proving triangle congruence. We have two postulates. One is called the side postulate, and one's called the side angle side postulate. And the first thing I want to do is get those two things defined. Side postulate. And we'll just simply, for the most part, abbreviate and call it SSS. And that says if the sides of one triangle are congruent to the sides of a second triangle, that is enough to show then the two triangles are congruent. So if the sides of one triangle are congruent to the sides of another triangle, then the two triangles are congruent. Let me just draw a triangle right here. Let me draw another one right here. Let me label this one A, B, C, and label this one X, Y, Z. Now, as you can see, I drew this one, I drew 3 units long on these. I drew these two 2 units long, and I'm guessing that these two are the same. My pencil's given out on me. So the side says if each one of the sides from one triangle is congruent to a side from the other, then the triangles are congruent. So triangle A, B, C is congruent to triangle. Now let's get this order right. A corresponds to Z, B corresponds to Y, and C corresponds to X. Triangle ABC is congruent to triangle ZYX. They are the exact same size. And to show that all the sides correspond and are congruent is enough to show that the two sides are congruent. That is one postulate. We have a second postulate, the side angle side congruence. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Now, included angle. If I have a triangle right here, I got this side and this side. Let's make this a little longer. And then I connect this one. Okay. If I have, I'm talking about these two sides, the included angle is the angle that is made by those two sides. And let's call this A, this B, and this C. And let me go like this. Let's mix it up a little bit. 1, 2, 3, 4. 1, 2, 3, 4. Now I've kind of turned it around on you a little bit, but this side is congruent to this side, and these angles are congruent. So QRS. A corresponds to R. So I'm going to put triangle ABC again. Is congruent to triangle Q. I'm sorry. A first, R first. Triangle R. B and Q correspond, and S corresponds to C. That is by side, angle, side. This side, this included angle on this other side. And a lot of times we won't write side, angle, side congruence, we'll write SAS. Now we're going to try a couple of proofs here. And we are relatively new to this, and I understand that. But I want to go through and show you how to prove two triangles are congruent using some of the things we've just learned. Now triangle CDE, the big triangle, outside triangle, is isosceles. And with CD congruent to ED. G is the midpoint of segment CE. G is the midpoint, so I'm going to guess that these guys are going to be congruent. And then we are to prove that this triangle CDG, this half, is congruent to triangle EDG, this half. And we have a side here that we're going to be able to show that these two are congruent with the isosceles triangle. We are going to be able to show with the midpoint that these two are congruent. The only side that's left is the side that they both have, and any side, is congruent to itself. So that's what we're going to do, and I'll even put 3 marks there. Now we have to build our case to do this. And usually what we do is we start with what we are given. So statement 1, I'm going to put triangle CDE is isosceles. And the reason is because they told us so. That was given. Now statement 2, because CDE is isosceles, let me put that S on there, segment CD is congruent to segment ED. And like I said, because that's definition of isosceles triangle. Two sides are congruent. So we just need to state, why can we say this? Well, because we know what an isosceles triangle is. Now statement 3, I'm going to take the other part that's given. G is the midpoint of segment CE. And we only know that because they told us that up here. That was given. These are given facts about this drawing. Okay, do remember, I'm trying to build a case using our old postulates, and this one I'm going to use side, side, side. And right now I have 2 sides that are congruent, one from each, and I'm trying to get a second one with G being the midpoint of CE. I know that CG is congruent, segment CG is congruent to segment EG, and that's what a midpoint does. And that's why I'm just going to write definition of midpoint. Alright, there's another side. The 5th statement I have here is that this common shared side is congruent to itself, and it is in each triangle. So segment DG is congruent to segment DG. It's congruent to itself. Now that is, and I haven't talked about that much with you, the reflexive property. Any number is equal to itself, any side is congruent to itself, any angle is congruent to itself. That is the reflexive property. That is my 3rd side, and that has helped us because we have shown that each side from this triangle is congruent to a side from this triangle. That is enough to show, and we end with what we were setting out to prove. We are setting out to prove that triangle CDG is congruent to triangle EDG, and we have done it. And the reason we have done it Reason number 6 is because of the side, side, side postulate. And that's all you need to write there. Okay, I have one more for you. Okay, we are given here that segment RQ is parallel to segment TS. So let me just put those arrows in there. That's what you do to mark that two lines are parallel. We are also given that segment RQ is congruent to segment TS. So let me put a mark on each side to say that this side and this side are congruent. Now, we are to set out to prove that triangle QTR is congruent to triangle STR. And as much as I think that QT and RS are congruent, I have nothing here that tells me that. But I do know something about parallel lines and alternate interior angles. Okay? So at some point, I'm going to put this in here. Alternate interior angles are congruent. And then I do know that we did this before. RT is in both triangles, and it is congruent to itself. So I think we've got a case for side, angle, side. Side, angle, side. Now all we have to do is put that in writing. The first thing we're going to do is segment RQ. We usually take what's given. Those are the first things we write. And sometimes we'll take what's given and we will build off of that. That is given. And also, segment RQ is congruent to segment TS. That was given. And this gives me a side. Now, I'm going to use side, angle, side. That's what we talked about. The angle is this one right here, and if we have congruent lines and if we have parallel lines and alternate interior angles, those alternate interior angles are congruent. Angle QRT, that's this one right here, is congruent to angle STR. And the reason that is because alternate interior angles are congruent for parallel lines. Here's what it does. If two lines are cut by a transversal, we can just put that in there to say we have parallel lines cut by a transversal. Don't worry too much about that. I'm being a little silly. Alright, so that shows I've got an angle from each triangle congruent. I got a side, and the segment RT is congruent to itself. It is in both triangles, so I'm using that reflexive property again. And if you'll look, I mark when I have congruent sides, I'll just put a S, or congruent angles, I'll put an A, congruent sides, I'll put an S. When I have that, what I have is the postulate that we talked about earlier, triangle QTR is congruent to triangle STR. I'm going to write SRT because I like that order better. I'm a little questioning that. And the reason is the side angle side postulate that we just learned. Alright, we are going to continue doing these, but this is all I have for you for now.